Hey guys, this is test 44, game 3. This is the Archaeological Sites game. It's an ordering game. We know this because we have the 5 archaeological sites that are visited in a particular order. For example, the first rule tells us the site visited second dates from the 9th century. That's implicitly telling us that there is an order in which the sites are visited. So this is ordering. I've got them labeled 1 through 5. In the order in which they are visited. We have the 3 people, F, G, and O, and then we have the sites 8, 9, and 10. So the first rule tells us the site visited second dates from the 9th century, so I've got the number 9 right there. Neither 4 nor 5 is visited by O, so we know that O is not going on 4, and O is not going on 5. Next, they tell us that we have exactly 1 G in the game, and that site dates from the 10th century. So if G visits a particular site, then that site will be from the 10th century. So if G, then a G10 vertical box. Next, if a site is from the 8th century, another conditional, then it is from visited by O. So if 8, then it's going to be an O8 vertical box occurring on the same number 1 through 5. So because we know that 4 and 5 are not visited by O, we can infer that they must not have been sites from the 8th century. So we can put not 8 under each of 4 and 5. Next, the site visited third is more recent than either the first or the fourth. So automatically, we know that the third site cannot be 8. We also know that it cannot be 9 because site number 4 is not going to be 8. Therefore, site number 4 will be 9 and site number 3 will be 10. Then from there we can infer that site number 1 is a little bit more ambiguous. Could be either 8 or 9. We don't know which. So, site number 3 looks like a pretty good candidate to be G, Gallagher, right? But the problem is that the rule tells us if it's G, then it's G10. It doesn't tell us that if it's 10, it must be G. So it's possible that perhaps either F or O could also be doing a site from the 10th century, and maybe the G10 block is going to occur on number 5. So we can't say for certain. It's still a little bit open-ended. I mean, site number 5 can't be 8, so it could be either 9 or 10, and it could be either F or G, but cannot be O. We already established it could not be O. So site number 3 could be any of F, G, or O. It is completely open-ended, totally ambiguous. Site number 9 can't be O, and it can't be G because it's 9. Therefore, it has to be F. For certain, we know this. Then number 1 and 2 can't be G because G is from 10. Could be either F or O. Totally open-ended. We cannot say for certain. So it's F or O. So that's our initial setup for the game. As you can see, we've determined quite a lot here. Very little remains ambiguous. Anyway, question number 13, typical orientation question. Only for this question, of course, they're asking us only about the people level, not about the centuries level. So we're going to have to use our people level quite a bit here. So you want to take one rule at a time, apply it to all 5 choices, looking for violations. The issue here is that these bottom 2 rules, the conditionals, are going to be completely irrelevant and useless to us because they are about centuries as well, 10 and 8, not useful. We're only concerned with the top level. So let's look at there can only be 1 G. Scan through all 5 choices looking for more than 1 G. You find that choice D as in Delta has 2 G's, not 1, and is eliminated for that reason. Next, we could run through the top level one by one. We know that only F or O could be on either 1 or 2, so any choice containing G on 1 or 2 is automatically eliminated. Choices B and C both have G on either 1 or 2. B has G on 1, C has G on 2, those are both eliminated. We're down to A and E now. Let's move forward a bit. We know that, let's see, We know that we have to have F on 4 for certain. Look at A and E, you find that choice A has O on 4, not F, unacceptable. A is gone, leaving E as our answer to number 13. Next, number 14. If we only have one 10 in this game, we know it's going to be 10 on 3, meaning that we do not have 10 on 5, we have 9 on 5, meaning 5 is not going to be G, it's going to be F. So that's the inference we get from this, telling us then that G has to be on 3 in order for us to have one G in the game. Because G requires G on 10, so G10 is happening on 3, not on 5. So now we know that we have to have G10 on 3. So we see that Ferrara could not have done the site visited 3rd. Of course, she's doing the site visited 5th, so E is gone. We know she's doing the site visited 4th, as always, so D is gone. And she could do 1 and 2. No reason she couldn't. It's possible in both 1 and 2, but it is not possible in 3 for certain. G is there, so C is our answer to number 14. Next, number 15. What could it be aside from the 8th century? Of course, we know it can't be 2, 3, 4, or 5. Those all have either 9 or 10. So B, C, D, E are all gone. And of course, we know A works because we could have a nice 8 right there on the site visited first. That's the only place we could ever have an 8 in this game. Next, number 16, they're asking us where couldn't G go in general? What could be places G does not go? Well, we know that G, of course, could go on either 3 or 5, but G cannot ever go on any of 1, 2, or 4. Those are the only places G could never go, because G could go on 3 and G could go on 5. Of course, he won't go on both of those simultaneously, but G could go on either of those. So any choice mentioning either 3 or 5 is automatically eliminated. A mentions both 3 and 5, B mentions 3, C mentions 5, D mentions 5, E mentions neither, so it's our answer. And of course, we know 1, 2, 4 was the answer to number 16 already. Next, number 17, how many places could we have visited by F? Well, we know we've got to have one G in the game, so 5 is not possible and E is gone. We also know that we never actually need to have O. We could lack O entirely. So we could have G on 3 or G on 5 and then have F on all the others. So we could have G on 3 and then have F on 1, 2, 4, 5, or we could have G on 5 and have F on 1, 2, 3, 4. Either way, we could have 4 Fs, so for that reason, D is our answer to number 17.